I want to end this section by reviewing a key skill you're going to need in Calc 3, and that is taking the equation of a function or a curve and being able to come up with its parametric equations. So we're going to look at two main cases right now, and the first case is given, let's suppose I give you a function, y is equal to f of x, and I'd ask you to come up with the parameterization over some interval. So let's do an example. Given this function, y is equal to 3x squared minus 1, let's find a parameterization between these points. Now, this is a curve we can sketch, so it'll look like roughly this. And I get to pick which direction I would like this parameterization to go. And so what's easiest when you're given a function like this is to just let your independent variable be t. So in this case, my independent variable is x, and then y is going to be, just plugging in t to here, 3t squared minus 1. So, and then in this case, my t, since it's the same as x, is going to go from -1 to 2. And we can plot this. I'd like you to be able to visualize this getting traced out. Okay, so I put in that parameterization here. This is just the GeoGebra demo. And now we're just watching as we trace this out for different t values. And so what I like to picture when I'm doing this, let's zoom it back a little bit, is that I picture parameterizations as just like being a little bug or a little particle moving through space in time. And so in this case, the little bug is starting here, and then it moves to here, and it takes it a total of 3 seconds. It starts at time -1, and it gets there at time 2. But what if I asked you to come up with a different parameterization for the same curve? So let's talk about an easy way to do that. Okay, so if I need another parameterization, maybe I want the bug to be moving faster. So I could say, well, let's let x be 2t instead. And then in that case, y is going to be, everywhere there's an x, I'm just replacing it with 2t, because I still want to trace out this exact same parabola. So now I'm going to get y is equal to 12t squared minus 1. But in this case, the t, if I'd like to still trace out from exactly this point to this point, then I'm going to need my x, since I want x to start at -1, then my t, so I'm going to just set up this equation to figure out where my t is going to start. This is at the start, and then the end is going to be 2, because x needs to be 2 there. It's equal to 2t. So my t is now going to go from -1/2 to 1. And again, if we go back and plot this, we can see now I'm going to get the exact same curve, but the bug is basically going twice as fast. And so this time interval, instead of taking 3 seconds, is only going to take a total of 1.5 seconds if we're thinking of this t as time. So that's an easy way to get 2 different parameterizations. So, okay, let's summarize that. That means the pro tip is, if you're given this case, then the easiest thing to do is just let your independent variable be t, and then your y will just be f of t. And you're going to do that between whatever your x values, in this case, a to b.
Okay, so let's look at a second case. Now let's have x as a function of y instead. So I want you to come up with 2 possible parameterizations for this curve. All right, let's just do a little sketch. So this is going to be a parabola that's opening to the right. Just do it here. Okay, something like this. And let's just put some points here. So this is starting when y is -2. It's ending when y is 4. And we can get the x values for the starting and end points as well, which will be useful for us in a minute. So notice when y is equal to -2, that x is equal to 12. And when y is equal to 4, x is equal to 48. All right, so the easiest way to parameterize, and what I would suggest if you're asked to parameterize something like this, is look at the independent variable, which in this case is y, and just let that be t. And then x can be 3t squared from -2 to 4. And notice if we parameterize like this, thinking of it as a bug, we'd be starting here when y is -2, and we would be moving along this curve in this direction. Okay, another way we could do it if I asked for another parameterization is I could really let y be anything else that can range from -2 to 4. So I couldn't let y be, for example, t squared, because that can't be negative ever, but I could let it be 2t or 5t or whatever I'd like that ranges from -2 to 4. So in this case, let's just let it be 2t. And in this scenario, my t would be going from -1 to 2 because I'm going twice as fast. Again, I'm still starting right here, ending right here, and moving along the curve in this direction. Now, a third way, and this is not what I would recommend doing, but I often see students try it, and so I do want to walk you through kind of what it would mean logistically, is I see students think, well, let me just solve for y in terms of x in this problem. And so if we do that, I'm getting x/3, and then I'm taking the square root. And this is often where students make a problem or make a mistake. So what did I do wrong? Right, I forgot that this needs to be plus or minus. Now, I can take this. This is now a piecewise function because I have one part that's defining the bottom part of the curve and another part that's defining the top. And so let's do the bottom. Let's start with the bottom. And a lot of times, like I said, students want to do this because you're thinking, well, let me just let x be t. So I'm going to do the bottom first. I'm going to do negative square root t/3. And then let's think of the values we're going to go between. All right, so this is also where a lot of times we'll run into problems because oftentimes I have students thinking, well, I want to start here and go this way. So if t is x, then I'm going to start at 12 and go to 0. But when I'm parameterizing, it makes no sense to write something like this because this is not true. I can't have t be greater than or equal to 12 and less than or equal to 0. So if I want to parameterize letting x be t, then I actually am going to be parameterizing this bottom part of the curve going the other direction, which is fine in this case because I didn't give you a direction that we had to parameterize. In Calc 3, we'll often be carrying or worrying about the direction, so that's why I'm pointing this out. But here I just said find a possible parameterization. So this is okay for the bottom part of the curve. But again, this is not giving me the whole curve. So I'm also going to need a whole nother parameterization for the top part, which is why this method, if you have something that's a function of y, I would just leave it as a function of y and not try to do this because it's easiest just to parameterize in terms of one parameterization. But if you go this route, let's do the top part, t/3. In this case, t is going from 0 to 48. Okay, and this is completely valid. And in this version, I have basically think of it as like two different bugs. They're both starting at time 0, and one of them is tracing out the bottom part of the curve, and the other one's tracing out the top part. Together, we get the entire curve traced out. So it's not a problem that these time intervals overlap or that they aren't consecutive. That's fine, because we're really just chunking up this curve into two different pieces. Again, if I had told you, oh, you have to do it in a certain direction, so let's flip this. This parameterization that you've given would not be the right direction. And again, I would stick with the easiest because this one would be going in the direction we're asking for. So let's say that you wanted to say, how could I change this here to go in the correct direction? And what you'll notice is that you're really stuck with your t being between 0 and 12, or that's a nice thing to kind of stay with here. But in this case, you can just switch your x to be 12 minus t because you're starting now when x is 12 and you're moving the other direction. And that means if you switch your x to be that you need to replace that inside here. So your y will be negative square root 12 minus t/3. And this would give you this parameterization, again, still in two pieces, but you'd have your first bug starting here, ending here. The second bug starting here, ending here. Okay, so just wanted to show you that because I often see students get confused about that. And I still would say if you have a function, just let your independent variable be t. So again, my tip in this case is just to let y be t and x be g of t. All right, so one of the most common first things that students try is they think, well, oh, I can solve for y here. So that's no problem. If I solve for y, I'm going to get y is plus or minus square root of 25 minus x squared. And that's true. And this would mean I would need two separate parameterizations, one for the top of the curve when it's a positive square root and one for the bottom. And so we can do that, but it's not the most efficient way. It's not the easiest way to parameterize a circle. Instead, what we're going to do, what we're going to recommend you do anytime you have a circle, is to think of a trig identity that involves a sum of squares. So wait for it. See if you can remember trig identity where we have a sum of two quantities squared. If you said, oh, I remember cosine squared plus sine squared is a trig identity that involves a sum of two squares, you're correct. And the way we can use this is obviously we don't have the sum of two things equaling 1, we have it equaling 25. So what we're going to do is multiply both sides of this by 25. Now I'm going to think about, okay, if x squared was equal to 25 cosine squared, and if y squared was equal to 25 sine squared, then when I added those two, I would definitely get 25. And so I have now some options because I can solve for x, take a positive and negative square root. I'm just going to stick with a positive one here for the simplicity. So I'm going to let x be 5 cosine t. And same thing, I will let y be 5 sine t. I could have had x as negative 5 cosine t. I could have had y was negative. Or I could have switched them around, as you notice. I could have written it as sine squared plus cosine squared equals 1. These were all going to give me ways to get to this circle. They're just going to involve starting at different points on the circle and moving different directions. So let's just see where I start and where I move if I use this parameterization. Let's start when t is 0. And notice if I plug in 0 for t, I get x is 5 and y is 0. So that's going to start me right here on the circle. And then let's go to pi over 2 just to see which direction we're moving around the circle. When t is pi over 2, x is going to be 0 and y will be 5. So I will be right here. So I'll be moving this way around the circle, and I can keep moving all the way if I'd like to trace it out once. So this is going to be the most standard common parameterization that you can use for a circle. It's just doing it once counterclockwise. Okay, so if you are not given things in terms of a function, then there's a couple of the curves that are not functions that you are going to frequently need to parameterize in Calc 3. And in particular, those are circles and ellipses. So let's start with the circle. And I'll kind of give you the easiest way to parameterize any circle. And then we'll look at some variations. All right, so let's come up with, let's assume for the starting case that we have just a circle centered at the origin. And so the equation of this is just x squared plus y squared is equal to some r. So let's say this one is 25. So the radius is 5, circled in Calc 3. So the tip is you're given x squared plus y squared is some radius, r squared. Then you're going to let x be capital R cosine t, y be capital R, or yeah, capital R sine t, and you're going to go around once. Okay, now you may have asked, well, wait a minute, this identity I could have written as sine squared plus cosine squared equals 1, which is true. And in that case, I could have let x be sine of t and y be cosine of t, which is also true. And notice what happens if you do that. It's not going to be my pro tip because you're going to see in Calc 3 a lot of times we are really interested in counterclockwise motion, or that's like our default. But if I want to flip this, let's see what's going to happen. We're just going to trace it out. So first I'm going to start at a different point. I will be starting at, when t is 0, I'm going to be x is 0 and cosine of, and then I'll be starting right here. X is 0 and y will be 5. And then let's move a little bit. Maybe let's just go, so sine of pi over 2 is 1. So I'm going to be over here, 5 for x and 0 for y. And so I will be moving this way. So if I parameterize by flipping them, I start up here and I move clockwise. So that's a nice, useful tip if you're trying to switch the direction. Okay, and you may say, well, wait, what if I would like to go clockwise, but I'd still like to start at the 0.50? And so there's actually an easy way to take our standard counterclockwise form and switch it to that. So notice the x, I'll just leave the same. But if I would like to be moving clockwise, I'm just going to take the opposite for the y, -5 sine t, and that will move me clockwise around this curve. So we have lots of options, but again, this is going to be the most common one that you're going to deal with. What I'd like you to think about next is what happens if I wanted to parameterize a shifted circle, which is also something that we're going to see. So let me clear us some space. Okay, so let's take this exact same circle and shift it. So now I'm going to have x minus 10 squared plus y minus 6 squared is equal to 25. Again, what I'm going to do is think of this in terms of trig identities that involve sum of squares. So the easiest trig identity, again, I can use, well, let's go back with my 25 cosine squared, 25 sine squared equals 25. And then this is helping me realize, okay, I just need x minus 10 squared to be 25 cosine squared. So I'm going to take the square root and just take the positive square root here. I'm going to get x minus 10 is 5 cosine t. And then here I'm going to get y minus 6 is equal to 5 sine t. And then you can solve for x. That means x is 5 cosine t plus 10. Y is 5 sine t plus 6. And this should help us because think about, again, if we're thinking of our bug, or this should make sense, because originally when our circle was centered at the origin, we just had 5 cosine t, 5 sine t, but now we need to move the bug over 10 in the x direction and up 6 in the y direction before they start moving around the curve. And so if you just, in fact, let's just even see when t equals 0, just to show you where you're going to start out. When t equals 0, we're going to be ending up here at x is 15 and y is 6, which is exactly this point right here. Okay, so that's again the easiest way to parameterize if you have a shifted circle. And this is going to lead us to what do we do if we have an ellipse? So it's going to be a very similar idea. Let me again clear some space. Okay, so let's say I give you this ellipse and I ask you to parameterize it. We're going to be reviewing this later at the end of this chapter, but if you recall, most of you probably covered conics in high school, and the way that you come up with the standard equation for an ellipse is you take this coefficient here, so basically it has to do with this distance from the center along the x-axis, and we're going to square that. And again, we're going to show you where this is coming from later. This is the standard form of this ellipse. Okay, so really I'm going to write this. It's x over 3 squared plus y over 2 squared is equal to 1. So if I want to parameterize this, again, I have a sum of squares. And so again, I can say, okay, wait, this reminds me of cosine squared plus sine squared. And in this case, since I have it in the standard form of the ellipse, I don't need to multiply this equation through by anything. I just need to set these equal here and here. So again, I'm just going to take positive square roots when I set them equal to each other. So now I'm going to get, and again, you can take negatives. It's just going to change which direction things are moving. But here I'm going to get x over 3 is equal to cosine t, and y over 2 is equal to sine t. So at the end, this simplest parameterization is x is going to be 3 cosine t, and y will be 2 sine t. And if I start at 0, let's see where that's going to put me. When t is equal to 0, x is going to be at 3, y will be at 0. So I will be starting right here, and I will be moving counterclockwise again. So these are the three most common situations you're going to see in Calc 3, functions of an independent variable that you need to parameterize, or circles shifted, and ellipses. And ellipses we can also shift. So the tip in general is given this ellipse. We're going to let x be a cosine t, y be b sine t, and just travel around it once.